Hello, this is the test of the robot base motors with the Arduino installed and the Sabertooth. That's a Sabertooth 2x12. I chose a 12. It's cheaper, and I don't think it's gonna have to reach the 12 amps per motor while it's in the house, because this is primarily going to be a robot inside the house. The code that the Arduino has is the sample code that came from the Sabertooth manufacturer, and that's exactly what I'm using. I tweaked it a little bit, and later we'll bring the robot outside to see how it actually does. Right now I have it lifted off the ground, and here's the power. The power is also going to the Arduino from here, so I'll be connecting it now, and then we'll see the process of what it does. This is the test setup of the Arduino hooked up to the Sabertooth 2x12 and two wheelchair motors. Right now the sequence is going forward. Both motors are turning in the same direction, and then it's ramping down slowly. It'll come to a stop and then go in reverse. The power to the motors is coming from two batteries that are in parallel, and the other batteries for future reference, for future expansion of other circuits, other Arduinos on the robot. There it goes. It's slowly going into reverse. It's ramping up. Now it should stop abruptly and then go in right turn position. It'll yeah, there it is. And you see now the motors are going in opposite direction. This would cause a right turn for the robot. This is in differential drive mode, whereby the steering of the robot will be controlled by the two motors. It's ramping down now, and then it'll do the same in reverse. Okay, this motor now is starting. This is to make the right turn, I believe. I'm sorry, the left turn. Yeah, by this turning in this direction, the vehicle will turn towards the left. And there's the other motor going in the opposite direction. It's ramping up. Now the plan is to have this Arduino only control the motors, and eventually this connection here, I have two of them, which are the emitters that each motor has. So the pulses will be coming to this Arduino. The software will be set up so that it knows the exact speed of each motor, and it'll get its commands from a master controller, another Arduino, and that Arduino will be controlling the sensors on the robot, such as the ultrasonic sensors. There they go, they both stopped. Now there's a 10-second delay, and the motors will begin again, but I'm going to turn it off. There it is, see? Going in, that's full speed forward. Okay, this is the first test of the robot base with the Arduino board attached. It only has the software that came as an example from the people who sold the Sabertooth, and that's what I'm using. I tweaked it a little bit, but this is the first outdoor test, and the Arduino is getting power from the Sabertooth. It's ramping down from forward direction. Now I should go in reverse. Unless of course the batteries died. Ah, there it goes. Probably going to crash into the fence. Oh, there it goes, doing its rotational move. And that's turning right, and it should turn left soon. It's slowing down the right turn. Or I should say ramping down, and now I should go in the other direction. It's going to go the other way. At the end there'll be a 10-second delay. It gives me enough time to get over there and disconnect the power. Hopefully. This is the code that I was able to get from Dimension Engineering, the people that sell the Sabertooth cards, the power controllers. And basically it's like a little sample test for a tank style operation of the motors. Okay, I did change a few things, not much, just the delays. And you can obtain this code also from dimensionengineering.com to have the motors run in differential drive mode. Okay, I don't know if you can see this. I don't know how clear it is, but that's why I'm giving you the website, dimensionengineering.com.